I'm Nathan Shively-Sanders, and I want to talk about parsing in Typescript. This is the third part of this video series, and I'm going to talk about specific things that you need to know about Typescript actual code, the actual parser. So this is going to be sort of a grab bag. Let me switch to VS Code actually to start off with. So in mini Typescript I showed off creating a node using an object literal. So the parser in Typescript still looks more or less the same. You're going through and saying the thing that you want and then creating something, but you're using a factory function. So in this case, factory create identifier. There's a factory function for all of the nodes. And then you call finish node. And that pattern is more or less the one you're going to use throughout the parser. Finish node will take the state of the parser, like the position and the end, those particular pointers, and it will copy them over to the node so that the node freezes the state at whatever point it was created. Another thing to know is that if you do create new syntax, obviously you need to write a parsing function for that and then slot it in and write parsing code for it. You also need to add it to a visitor. So this is a giant table that has every kind of node in it, and just manually visits them so that you can use it elsewhere. So if you have, say, a qualified name, that's really simple. It has a left and a right, so you visit node left, then you visit node right. If you have something that's a list of something, like a modifier list, then you call visit nodes rather than visit node. One non-obvious invariant here is that you need to visit them in the order that it was parsed, so textual order. The first things need to happen first, and so on. And for qualified name, this is really easy, like it's obviously left, then right. For something like JSDoc JSDoc parameter, it is not obvious because there's two different orders to parse it. And the parser actually creates a Boolean. It sets a Boolean. If the name is before the type expression, you visit it one way. If the type expression is before the name, you'll visit the other way. And JSDoc syntax is uniquely horrible, I think. So you shouldn't run into this, but it's just something to know in case you do create one of these functions. All right, I talked about how to create missing nodes in the mini Typescript video. Here's how you do it in Typescript itself. You create missing node, you say what kind you want, and then you pass in an error that should be logged. So in this example, we're parsing a call expression, and there was a question dot, but there wasn't anything after it, so we stick an identifier in there, and notice how that missing node gets used as if it was the thing you were calling with the question dot. It's just that thing happened to be missing. So that's pretty straightforward, I think. Context flags are one of the many flags that are used in the Typescript compiler. This one is set as we parse the file, and it's used for simple things like let and const. So when you're parsing a variable declaration, when you have let and const, the flags will be set as you parse, and then later in the checker or something, it's easy to find out if you have a block scoped variable just by saying, is it let or const? More interesting during parsing is these context things. So these are set as you start a context and unset as you leave a context. So when you're in a yield, certain identifiers are always treated as keywords. Sometimes you want to disallow conditional types. So nested conditional types with no parentheses are ambiguous. And to resolve this ambiguity, the parser sets this flag so that nested conditional types are not allowed in certain ways. Obviously, you can get around this with parentheses, but this Boolean allows the parser to easily avoid that ambiguity. And context flags are set in finish node. Well, they're set all over, but then they're copied into nodes inside of finish node. So that's one reason why you need to call finish node. Okay, let me see where I got to. All right, so the last thing I want to talk about is look ahead. Look ahead is sort of an exception to the thing I talked about in the first video, where the parser is always looking at only the next token. Sometimes you really do need to look further ahead. For example, arrow functions are very ambiguous, and so we're looking ahead a lot of the time to find out if we're looking at an arrow function. But look ahead is expensive. So anytime you call look ahead, you want to guard it inside of a check to see if the context you're in, like the next token, could at all be right. So if we're checking for a parenthesized arrow function, there's only 3 tokens it could be. We don't know if those 3 tokens are going to be an arrow function, but that tells us that we can at least go and check. And you can see below here, there's like, this is the case where we definitely have or definitely do not have an arrow function. All right, so let's look at what actually look ahead does. So I'm going to call a helper called speculation helper, and the speculation helper saves the state of the parser, and then we'll later restore it after it calls the callback. The scanner also has a function, look ahead and try scan, that does the same thing. It calls a helper that saves the entire state of the scanner and then restores it when the callback is done. And so saving and restoring the state is not that expensive. The expensive part here is when you are at a position and you parse for a while, you find your answer, usually just like a Boolean or something, and then you throw that away and start back where you were and then reparse it. So anytime you're parsing something twice, you're doing twice as much work as you need to. There is an exception to this. If you call try parse rather than look ahead, let me see. Yeah. So these functions look the same, but if for the look ahead case, as soon as callback finishes, it's always going to roll back to where you called look ahead. With try parse, if the callback returns something truthy, then the parse will commit. In other words, it doesn't reset your state, and you continue parsing from there. So try parse is used more commonly throughout the parser because it's not as expensive in the case that it succeeds. I think that's all I wanted to talk about for the TypeScript parser, and I think that's the end of this trilogy of videos. Thanks for watching.